My name is Geoffrey Lessel, and today I'm going to be introducing something I'm calling Vox. It is a static site generator for Elixir. I almost renamed the talk to a static site generator for an Elixir lover, because this is a static site generator that I wanted, I needed, I built for me, but I'm hoping can be a static site generator for you as well, as fellow Elixir lovers. So hopefully you can help me make it be that. So some background, I'm Geoffrey Lessel. I've been an Elixir lover for 9 years. Found a new pet last night. That's Willie. I learned his name was Willie Bite. I didn't make that up, but I thought it was pretty funny. So I've been an Elixir lover for 9 years. I'm an odd year ElixirConf alum speaker. So I've spoken at 2017, 19, 21, 23. So I'll probably see you in 25. I blogged at geoffreylessel.com. Used to blog there quite often. But then I wrote a book called Phoenix in Action for Manning, and at that point, I may have written all my words out for a while. So once I started that book, I stopped blogging a bit. But I was hoping to restart the blogging exercise, and that kind of led me on this journey. That's part of what led me on this journey. And I'll get into more of that a little bit. There's a code provided by Manning, it's PHX23. They didn't tell me what percentage off that is on the products, but I do know it's active for everything on Manning.com. Doesn't have to be my book, it could be anything. And if you follow that link, it gives me a little bit extra cut on whatever you buy, so I appreciate that. I also made Build It with Phoenix, which is a new tutorial series, a video tutorial series, going through step-by-step how to build an application in Phoenix using LiveView and all the new cool stuff that LiveView gives us. So use access code ElixirConf to get 15% off through next week. And I'm also involved in various other Elixir shenanigans in the community, so I'm around. So how did this whole thing get started? Well, as I mentioned, I started the Build It with Phoenix project, and there's some things I wanted for this page. I just wanted a simple landing page on builditwithphoenix.com that I could use as kind of a marketing page. So it needed to be super simple. Like, I didn't need a whole lot. But here's some things I wanted. I wanted to write Elixir, because I love Elixir. I wanted to use HTML. I actually like writing HTML. A lot of people don't, but I kind of do. So I wanted to be able to write some HTML. I wanted to have a mirrored directory structure. Now, what does that mean? So if I put a file in a folder, then on my local directory for my site, then I want that same file to be in the same path on my website. I just kind of I don't want it to magically resurrect itself somewhere else. If I put it here, I want it to be there on my site. I wanted to use EEX because, again, I like Elixir, and I'm familiar with EEX, so I thought that would be fun. I kind of wanted the idea of templates. We'll get into that a little bit. I like Tailwind, so I wanted Tailwind. And I wanted it to be extensible. This is starting to get to the point where I'm starting to think through, well, what if I built something? I kind of wanted to be able to be extended or extensible for other people to be able to add to it as they see necessary. And I wanted the opinions that it held to be light. So if it had an opinion, then I didn't want it to be forceful. I wanted it to be lightly held. So here's some things I looked at as I was trying to figure out how I was going to build builditwithphoenix.com. GeoffreyLessel.com was built on Jekyll, and my history is a lot of Ruby in my background. But for this, it was just too much Ruby. I've tried to resurrect GeoffreyLessel.com a couple times, and there's a whole bunch of Ruby dependency stuff that was bad for Jekyll, and I was just like, I'd forget it, so I didn't write a blog post. So this Jekyll was too much Ruby for me for this particular project. I thought about Levendy, Next.js, Gatsby, and even though I do write a lot of JavaScript, that was a little too much JavaScript for me for this particular application. I did find an Elixir package called StillEx, and I looked at that, but it seemed like, and I have to give this disclaimer, I didn't actually install it and use it, but from the documentation and the website, which was actually pretty slick, it looked like they were pretty set on using Slime, which I wasn't familiar with, which is like, I think, a templating engine. So I was like, I don't really think that's what I want. And it turns out they actually archived the whole repo on July 6th, which I found out last week as I was preparing this talk. So I'm kind of glad I didn't choose to go with Still. And then there's one called LambdaPad that someone told me about. I didn't find it, but someone told me about it. And it's a little too Erlang-y for me. And I know that Elixir is basically just Erlang, but there's a feel for Elixir and there's a feel for Erlang, and that one felt a little too much like Erlang for me. So I was like, it's not for me. So here's what I did. My background, a little divergent, a brief history of the past 4 or so years of my projects and talks. In 2019, I wanted to sim race. And so what did I do? Instead of sim race, I built an exterior steering wheel display. So I used Scenic and Elixir to capture UDP packets over the network that my simulators were throwing out, and I wanted the telemetry data to create a steering wheel display. And that ended up being a talk. So instead of sim racing, I ended up writing these couple libraries that made this thing happen. 2020, I wanted to make music. I love synthesizers, especially hardware synthesizers, external synthesizers, and I wanted to make music. What did I do instead? I made a MIDI sequencer in Elixir using Phoenix. So in Phoenix, you can actually program. You can see me actually programming an external drum machine with Phoenix right there. This was at Impex. I gave a talk about this. So instead of making music, I wrote a library that allowed me to do MIDI in Elixir. In 2021, I wanted to learn assembly. And I had heard that a good place to start assembly was like the 6502 processor, kind of an older processor from the 70s and 80s, because there wasn't a whole lot of opcodes, and it's kind of easy to understand. Plus, it was in a lot of computers, like it was in the Commodore 64, the NES, the Apple II. So I was like, all right, well, I'll start learning that. And as I was reading through about how to write assembly, all the emulators I found were directed specifically towards a computer built around the chip, around the CPU, where I wanted just like the pure CPU emulation. So what did I do? I built an emulator of the 6502 processor in Elixir using Phoenix to be able to see exactly what's going on in the CPU at any point of time. And that was 2 years ago at ElixirConf. I presented on that. So this year, I wanted to build it with Phoenix.com, and instead I built Vox, which is a static site generator. So I keep falling into these traps. I was talking to Rahman earlier about how we want something, we want a tool, and instead of doing the thing we want to do with the tool, we end up building the tool itself. So I fell into the trap, classic trap. But I also think that there is something to be said for fun side projects that you just do just because you want to learn something. And I have a friend called Tim Morgan, his name's Tim Morgan. He has this site called justforfunnoreally.dev, and it's really just a site about the joy of making something just because, just for fun. So go check that out if you're interested. This is along the lines of a project like that. It's something that I wanted. I didn't know how the static site generator worked, so I was like, well, this is a good way to figure out how it works, so I'll build one. All right, so let's look at some code. A lot of this, like most of the code in the project is going to be displayed on the screen for you in the next few slides. There's not a whole lot of it, but it took me a long time to get there. And I'm going to kind of run through how I found the static site generator should work. And of course, there are other opinions on that, but in my past projects, I had never really looked into what other people were doing. So like for an emulator, I didn't look at how people were writing emulators. I just decided, well, I'm writing one. I don't know how they work, so I'm just going to figure it out. So there's pros and cons to that approach. The con is, like, there's potholes and rabbit holes and all sorts of stuff that you could fall into that people in history have already overcome, and they're like well past that I'm just going to fall into. So that is a con. A pro is I've got to figure out how to overcome that, and in the process, I learn why not to do one thing and how to overcome that by doing a different thing. So there's probably still some potholes in this code that other people are like, we did away with that like years ago. I don't know why you're still dealing with that. Okay, so here's the process. The first thing we need to do is find the files that we need to compile for our static site generator. And this code is really simple. I mean, all we're doing is finding the files in a root directory, and literally we're just finding everything. And we're going to collect those. So the collection for each of those files, we're going to put them in basically a gen server called the collection. And that's actually ended up being a name collision that I'm hoping to rectify at some point in the future. We'll see the name collision here in a minute. So it's an unfortunate naming, but right now it's called the collection. And we're adding them as unprocessed. So it's the beginning of the thing. We just found them. They're unprocessed files. So how are they added to the gen server? Well, I have this file struct that kind of keeps track of all the different metadata I need as it goes through this whole process. So you can see we have like the bindings, collections, whether it's compiled or like the compiled output, the content, destination path, all that kind of stuff are things that we're going to be updating as it goes through the process. So now we found the files, the file finder, we have the file compiler. And this steps through with a pipeline all the different steps we need to do to compile the files. And we're going to go through these one by one, but this is an overview of the process that I came up with. The first step is to compile the files, right? So for every file that we found, We take that list of files we found and pipe them into here. So we're going to reduce over that list of files. And for each one of those, we're going to match on the extension name. The first extension name I came up with is .eex. I wanted to write EEX files. So all the files that I've written so far for Vox are .html, .eex. This is where it could be controversial. I haven't said Markdown yet, right? There are people who are like, I want Markdown. Like, if it doesn't have Markdown, I'm not going to use it. I'm like, it could use Markdown. Like, for Build It with Phoenix, I didn't need Markdown. With GeoffreyLessel.com, I'll probably need Markdown. So I'll need to either add Markdown ability or someone else will. But this is kind of where it would be done. So we look at the extension name and say, what do we do with EEX files? So the first thing we do is we compile the file. There's a module called EEX, and as you would imagine, it deals with EEX files. So it compiles that file down into an abstract syntax tree. And we'll see an example of that here in a minute on the next slide. We're going to store that syntax tree. We're also going to compute the destination path in this step so that, you remember how I said the mirrored directory structure? We're just chopping off the EEX at this point, and we're going to say the destination path is exactly where you found it, minus the EEX. So if there were other preprocessors, like a Markdown processor, you could potentially have like .html, .eex, .md, or something like that, to where first it processes the Markdown, and then it processes it with the EEX, and then it goes out to the HTML. So that's something that we could add in the future. And then it updates this file struct to be able to add to that reduction. If there's no extension, it's typically a directory. And in that case, we don't care about it. That could be changed in the future if there's files that don't have extensions, but right now it's not handled. And finally, there's this idea of pass-through files. So if I have like a JPEG or a CSS file or icon files or anything like that that I need to just be in the same spot, I don't need to do any pre-processing with them. I just need them to be, need to compute the destination path, and then do nothing with it. Just keep it in the list. All right, so that's how we compile the files. That's that step. The next step is compute collections. Now, before I go into, this is where that name collision comes into effect, where the whole collection gen server kind of collides with the idea I have of collections. So there's only, I think, 3 things that are unchangeable right now in Phoenix, or sorry, not in Phoenix, in Vox. The first is the idea of collections. So you can think of a collection as like a grouping of pages. So, for example, on a blog, you would have different posts. Posts would be your collection. It's just like different pages would be in a posts collection. So at the top of your file, your EEX file, which is typically where you'd put like front matter or something like that for a Markdown file, you can use EEX, so you just, the angle bracket and the percentage sign, and then you start binding variables. One of the variables you can bind is one called collection. So how do we find the collections that this file belongs to, or even exist? So every file, well, first let's look at this compile string. So this is the idea of that abstract syntax tree I was talking about earlier that we've compiled our files down to. Well, this file is ElixirConf equals fantastic, right? That's all we're doing in this EEX template. And we compile that, we see that there's a colon equals, so that's the operation we're running. And then later on, there's ElixirConf, that's the variable name we're binding. And then fantastic over here is the value that we're binding to that variable. So all I need to do is find out everywhere that I'm saying collection equals, and then find out what those collections are going to be. So that's what we're doing in this compute collection step. Here's the code for that. So again, we're mapping all of the files, and we're going to bind this collections idea. We're going to take that compiled output, and there's something called a pre-walker, which is essentially just turns that AST into something that you can iterate over. So I'm enumerating over that with map, and within there, I'm pattern matching on that equals, the collections binding, and then the value for that collections. I'm adding all those collections to the gen server so that the gen server knows the idea of what are the collections available in this website. Let's see, my mouse went over there. Okay, so, oh yeah, there's that. And then anything else, we just pass it on through. And we update the struct for that file with the idea of what collections it knows about or is a part of. All right, so now we've computed the collections. Now we need to compute the bindings. So we can kind of think of this compiler as, I'm not a compiler expert or anything like that. I've read a little bit about them, but this is kind of like a 2-pass compiler in my mind. So the first pass, you kind of have to collect all the variables that you need to know about, right? You have to look through all the files and say, what are the variables? And so you have this collection of variables, and then you go through and compile it again and say, now that I have these variables, let's use these variables in the new compilation step. So this is that first part where we're trying to find out what are the variables. It's kind of like the collection step, but a little bit different. So if we take that compiled output from the last slide of the ElixirConf equals fantastic, and we eval that, this is the output that it would provide from EEX. That first part of the tuple is the output from the EEX template. In this case, we didn't output anything, so it's an empty string. But the second part is the bindings in that file. In this case, we did say ElixirConf equals fantastic, so that is the whole amount of bindings we have in that file. I want to find out what those bindings are. So this is what compute bindings does. First of all, it takes all the assigns that it knows about currently from the collection. And then for every file that we know about, we're going to iterate over those again. And we're going to capture the bindings when we eval quote those files that compile the output. You can see here that I don't care about the content right now, and because we don't know the variables yet, and we don't know all the assigns that it needs to know about yet. We just want to see what those bindings are so we can pass that on to other files that need them. And then here, I wanted the ability to, like if you're iterating through some posts, like if you have an index page for your posts, and you have all your posts listed, you kind of want to know what the post title is, maybe a description, maybe like a preview image, the path, all that. And I thought it'd be nice to be able to access those through like a map dot type syntax. So I'm essentially updating the file to add each of those bindings as dot title, for example. So it'd be file.title, file.description, that kind of thing. So that's what this step is doing here. All right, so we've computed the bindings. Going back to the overview here, we've done these first 3 steps. The next step here is update collection. And this is called twice, and these are corresponding to the 2 different passes of the compiler that I was talking about earlier. So now we've done that first step where we know what variables we're going to have to care about, the bindings. So we're going to update the collection, and then we're going to do another step of the compiler and update the collection at the end with the final output. So now we're at that first step, we need to update the collection. Next is evaluating the files. Let's look at that. So here, excuse me, again, we're going to map over all the files. And if it's a pass-through file, we don't need to eval anything. It just passes through, right? Excuse me. For files that are evaled, the type is evaled, then we're going to eval the quote with the compiled. And this time you can see I actually don't care about the bindings. I just care about the output, the content. So this is where we're computing with the assigns that it knows about. You can see in the assigns list there, the third argument for eval quoted. I'm sorry, the second argument for eval quoted. We have the assigns, we have the collection assigns. So from the collection, all the assigns it knows about for like collections. And then the files bindings, or the files assigns, to add it, pass that back to the file itself. And then we're updating the file struct again with the content of the file. After we eval the files, we need to find a template. So I mentioned there are 3 things that right now are opinionated about Vox. 1 is the collections idea. 2 is everything has to have a template. And 3 is everything has to have a root template, essentially. So this is where we're finding that template. So essentially we're mapping over, again, we're iterating over the files, and for each one of those, we're calling put nearest template. For a pass-through file, it doesn't need a template, right? So we're just passing it through again. For everything else, however, we are grabbing the source path and the bindings from the file, and in the bindings itself, you have the ability to say, for this file, this file is going to use this template. So you can say template equals. And so we're looking in the bindings to say, does it specify a template for it? If so, then we're going to use that template. And we're going to update the file with the template name for that file. Excuse me. If not, then we're going to do this find template in this and parent directory. So the idea is, if you have like multiple subdirectories deep of something and you have this file, it's going to look first to where that file is to see if there's a template for that subdirectory. If it doesn't, it's going to look in the parent. If it's not there, it's going to look in the parent, and so forth until it finally hits the very root of your source directory, and then it's going to use whatever template's there. To be honest, like builditwithphoenix.com, the template file is essentially, it just passes the content through. There's no markup in there at all. It just says enter content, and it just renders that. So the idea of it having to have a template, I'm kind of rethinking because there's some times when maybe it doesn't have to have a template. But right now it has to have a template. And it has to be called _template.html.eex, which you can see here. So this is where it actually finds the template and checks if it exists. If it does, great. If it doesn't, then this is where it recurses and looks for it in the parent directory. All right. Now we're going to insert the contents of the file into the template. So we have this EEX file, let's say it's a post, and you have a template that deals with posts, and then you have your root HTML content. So we're going to kind of insert it into 2 layers. So we got the first layer, or the top layer is your content, inserted into a template, inserted into the root. This is where we're inserting it into the template and the root, actually. So for again, we're mapping over the files. For every one of those, if it's a pass-through, we don't care about it. We'll let it pass through. Otherwise, we're going to, you can kind of ignore lines 7 through 13. That's me trying to filter out some bindings that the EEX engine put in there that is a little bit noisy, and I don't care about them. It's stuff that it added. But past that, we can look at this templated. So we're going to eval the file of the template with the assigns. We're going to merge the bindings of the file with the inner content. So inner content is another one of those special words. So like the assign inner content, so the @ inner content of any template is going to render whatever the file is being put in there. So that's important. We also are going to merge again. So that's the first step where we inserted the file into the template. Here we're updating the assigns again to where all the new assigns are needed, and we're going to finally insert that template into the root. And that's where the final comes in. We updated the file struct again, so now we have the final output of our file. All right, now we're done compiling. So what do we do now? We write the files. So there's a file writer, and honestly, it's a bit verbose, but it's pretty simple. All it does is write files where they need to go, using the information we already have about the destination path and the content. I'm not going to show any code on that because, again, pretty simple. The other thing I wanted to do was have a simple generator, a Vox new generator. And Vox is interesting, I guess, because it's only mixed tasks at this point. Well, minus one function that I provide, which I may or may not continue to provide, called partial. But it's all mixed tasks, which, again, I didn't have a whole lot of experience writing before, but this was a great opportunity for me to learn how to write them, right? So this is a very important mixed task that I wanted to create so that people could basically stand up a new site pretty simply. So here's mixed vox.new, or at least the code that runs that. Ignore most of this right now except for the use vox new templater, because most of that code at the beginning, all those templates, that relies on code that's in the templater. So let's look in the templater. This is where macros really start showing their use. I had the problem of I have these files locally or in my Vox repo that are template files, like, for example, a standard root .html.eex file that generates, the doc type in HTML, the boring stuff that you only want to write twice or maybe not even write at all. So I have that. How do I copy that over to someone else's path that they tell me where to copy it? So if someone says mix vox.new.elixirconf, how do I transfer that root file over to ElixirConf on their file system? And I tried all sorts of things, and if you compile it and just say, hey, grab this file, then it's going to try to look on their file system for that file, which is not going to be there. So the idea that I came up with was, Phoenix seems to have figured this out. I'll look in the Phoenix source code. So we, at the speaker dinner the other night, we're talking, a few of us at the table, we're talking about how source code diving in other languages seems to be more prevalent than in Elixir, and that's probably because Elixir has the reputation for great documentation. Like, there's times we just don't really need to dive in because it's documented really well. But in this case, there are some times where you just want to go in and see what other people have done. And this is one of those times where I looked at, how does Phoenix do some stuff like this? And I got some great ideas. So a lot of this was taken as inspiration from the Phoenix generators. The first part is this using. So it's a macro using. When you say use something, this is what's called. And so we're basically importing the module. This is an interesting thing that I found, module register attribute. You can't see the top of it there. There we go up there. Module register attribute. This is, okay, so when you have the ampersand, like the @ symbol, and then a name, and then whatever in a module, that's like a module attribute, right? So you can actually register, pre-register a module for, pre-register an attribute for a module, and say accumulate true. And what does that mean? It means if you say it multiple times, it basically just accumulates instead of overwrites. So it's if I say @geo1 and then @geo2, it doesn't overwrite the 1. Now it's 1, 2, the @geo value. So this is where I'm registering the attribute and saying, every time I call templates, I want you to accumulate the information. And then that's used, let me go over back to this slide, that's used down here where we're defining a macro called template. And we have the name of the template and then a flag that I'm using later to determine whether or not I actually need to render that template or not. So that's just basically adding the template name, that little tuple, as a module attribute. Then there's this before compile. This is something also I learned going through some of the module source code, or module documentation actually. This was great in the documentation. But you can tell a module some things that it needs to do before it compiles itself. And so these are some things I needed to do before I compiled my mix vox.new generator file. That first thing is I'm grabbing a template path, and I'm getting the attribute of all the templates that's defined in the module currently, iterating over those, and I'm compiling them. Once I compile them, I'm marking them as an external resource, marking them as a file, and then I'm defining a function called renderTemplate for each of those. So I now have multiple functions. Every time I call template a file name, I now have a function called renderTemplate with that file name that renders out the value of the compiled output. So you can see here, do unquote compiled. So we compiled it, and now when I call that function, and it's pattern matched on the file name, I can have that output compiled. So now it's not just a file living on a file system, it's actually compiled code. So that when someone runs mixvox.new, all it has to do is call that function, and we have that output of the template file we can write somewhere we need to. That was an important discovery for me. All right, moving on. Back to the vox.new task. So now we know what all those templates are doing. So you can see that on line 11, for example, there's esbuild after that template. That is essentially a flag that I'm using to say, we don't need this file unless they're using esbuild. And we'll see how that's used here in a minute. For everything else, there's a default value of true, so just always include these other templates. And we'll see how that's implemented here in a minute. There's also this idea of the template string to replace, kind of a magic string, to where if you ever run like mix new, you know that some of the file names are based on what you tell Mix your app name is. So this is how I'm saying on my file system, I'm saying the name is app, like all app esbuild.ex. So let's show you, like there's the string. So it's app. So locally, it's just lib app.esbuild or /esbuild.ex. But as I'm going through later, I'm going to replace that with the name of the project that the person is building, the user is building. So those are those templates. Next step is the actual task itself, so running the task. This is the code for that. The first part is pretty simple. We're just grabbing the options that the user passes in. Right now, there's an esbuild option to include esbuild. I do have a tailwind option is working as well. It's just not in the code quite yet. So after we do that, we kind of infer some things based on what they wanted their app to be named, so like the path and all that. We're building this project struct. And what do we use that project struct for? We use that in generate. And the generate function here used to be like multiple lines long, but as I learned more and refactored, it went down to like just this 2 lines that could really just be 1 line. So all we're doing is with that project, we're copying the templates. So copy templates, what does that look like? Again, we're iterating through the templates. For each of those, if it's true, which is the default, again, for the that template macro, it's the default true, we're just going to copy the template. If otherwise, we're going to check the flag to see if on that project struct, that flag is enabled. So in this case, the only flag is esbuild. So if they say, hey, we want esbuild, then we're going to copy it. Otherwise, we're not going to copy it. And this is where it's actually doing the copying. So again, I mentioned that we're defining functions for every template called renderTemplate with the function name, or sorry, the path of the file, of the template. So this is where that function is being called. So we're getting the contents back from that function, and we're basically putting that into the content of the file. We're writing that out to the file system where it needs to go. And that's vox.new. So did it work? I'm going to show you a couple things here. The first, of course, doesn't show up for you guys. There we go. So I'm going to run mix vox.new, and I'm looking over my shoulder because I have my screen not mirrored. But let's call it mix.new or mix new, sorry, vox.new ElixirConf, and let's use esbuild in here. So you can see here it's going to generate the files that we need. Those are the templated files. If I go into that subdirectory, I need to change one thing real quick because, and this is in the documentation at the moment, there is a published 0.1.0, but it was really just me reserving the name like months and months ago. So don't use that. But you can use the current GitHub code. So if I put in GitHub here and change in this, it's Lessel/Vox. Write that, and then I'll do mixsteps.git. It's going to grab that code from GitHub, compile it, or not compile it, but grab that into our dependencies. Now I can run mixvox.dev. What that's going to do is going to compile all the code and start a dev server that watches for file changes. You can see that there's some warnings here. They're ugly. As I mentioned, there's like a two-pass compiler. The first pass is what's presenting those warnings. It's like, not these warnings, but those warnings. Assign inner content, not defined, or not available. It's like, I know it's not available. I don't care it's not available. But unfortunately, I can't figure out a way to silence those warnings. And in the source code, where that warning is generated, there's a to-do in the source code that says, for version 2, raise instead of warn. So I got to figure something out before that starts raising. All right, so now we have a dev server running here. Let's go over to the local host. Let's see, local host. I can't see. Let's do 0.0. You tell me, 0.0.0.0, 4,000. Is that right? Did I type it in right? All right. There is the site that Vox generated from Vox New. So you can see there's one post. There's like this header here. I'm not a designer, but I did the best I could to make it look at least presentable for today. So there's welcome to Vox. Just information about where you can find the template files. There is a config file, so you can configure your source directory and your output directory. Right now, the default is site for source and _HTML for the output. And then I have one blog post here of just like a hello world type thing, just so you can see how collections work. You can go in there, modify the source code as you see fit, and as you modify things, it should automatically reload and publish your changes for you, which is pretty cool. Other thing I wanted to show was build with Phoenix. That was the whole idea behind this thing. And now build it with Phoenix here is built with Vox. You can see at the bottom here, I added this on Tuesday night, built with Vox. So it's actually done the job for me. And there's a couple of different ideas I used in here from Vox. First is the idea of a partial. So this is actually a partial. So this is rendered twice, this little sign up email address thing here. That's rendered twice, and I thought, well, I need a partial. This is actually the only thing Vox provides right now that isn't a mixed task. So there's a vox.partial function. I don't know if I'm going to keep it or not, but right now it's in there. You could just as easily define your own partial function, which is actually what I did down here for the social icons. I defined a function in my own lib directory for build with Phoenix, and said it's just called social link, I think it's called. And I passed some variables into that social link function, call that in my template, and so that's how those social links are generated. So I would say, yes, it is working as intended. All right, so where do things stand? Right now, what's working, what's not? Working, the installer is working, so mixvox.new, we just saw that. ESBuild's being included, mixvox.build. I forgot to show you, I'm kind of running out of time, so I'm not going to go back, but there, in the console log, there's actually a console message for you as well. It says like, hello, ElixirConf, find this in app.js. So ESBuild's running in the background, it's built that file, and it's outputting something in the console from the mixvox.new. So mixvox.build works right now. So mixvox.dev actually uses mixvox.build underneath to build out all the files for the server. What needs work? Well, those annoying warnings I showed you, I'd really like to take care of those somehow. It needs better errors. So there's sometimes where an error shows up, and I don't even know where it's coming from because of the macros. That's, maybe that's why we shouldn't use macros. Tests, dear Lord, tests. Like confession time. I'm horrible at tests, so it needs tests. It also needs other processor plugins, like I mentioned, Markdown. Some people are like, I'm not going to use it unless it uses Markdown. So if you want to add a plugin for that, please do. That'd be great. And then some general refactoring, like I mentioned, that name collision. That's unfortunate. Could fix things like that. It'd be great. All right. So Vox needs you in general. I do have some codes and stuff before we wrap up. Build with Phoenix again, 15% off using ElixirConf. If you don't buy it, sign up for the mailing list at least, because I'm giving away two versions next week, or 2 courses, I guess. And then Phoenix in action. That website just redirects you to Manning's site with my little code tacked on, so I'd appreciate it if you use that. If you use code PHX23, again, I don't know the amount. It says 30%. I don't know if that's what it is. I asked them, but I haven't heard back. I just know that's the code. And I'm also giving away 2 ebooks next week as well, so from that same mailing list, so sign up for that. All right, so find me in Vox Online. All these slides are at ElixirConf2023.geoffreylessel.com, or that's where that QR code goes. So you can follow all the links, see all the code, all that kind of stuff. It is on GitHub right now. It's public. I publicized it Tuesday night. There's 3 of you who have found that already and started. So good job. So you're early in. I'm also Geo Lessel pretty much everywhere. There's social stuff going on, except for Elixir Forum, where I'm Geo. Blog at geoffreylessel.com, build@phoenix.com, phoenixinaction.com, a couple other places you can find me. Anyway, thank you so much. I really hope that you use Vox. Like, I'm anxious to see what you can build with it and how we can all improve it and make it something that Elixir people can use as they want to build static site generators, because it's really a great language for something like that. So thank you very much.